Hi, welcome to the second video lecture, and here we will we'll continue the discussion on Introduction to Database Management Systems, and here we will discuss about databases, database management systems, and related concepts. So let's look at the objective that we have set up for this lecture. We will understand the common usage of database systems, and then we will try to understand the meaning of the term database management systems, and the database environment. Different types of functions we'll look at, like what database management system will be able to do for us, and then we will look at the advantages and the disadvantages of database management system. And towards the end of the lecture, we will also create a very small database system using MS Access. Alright, so let's get started. Now the question is that, do we really interact with database systems? And how often do we interact with database systems? And where exactly do we interact with database systems? So there are a lot of cases in our day-to-day life when we interact with the database management system. So let's look at the first case, which is about buying something. So you may purchase an item either at a store, like you can personally go to the stores like Walmart, Costco, or Target, and you may buy some stuff there, some items there, either at the physical store, or you might do this shopping even online. Now, whether you are purchasing some item online or in physical store, you will be interacting with database systems. Now let's take the scenario where we are purchasing the item using a credit card, because this is an interesting case. Why? Because here, in this process of doing a transaction, which means buying an item from the store using the credit card, there are at least two database systems which are involved. So what are these two database systems involved? Well, the first is the database system of the store. So if it is a physical store, say Walmart, then yeah, when you pick an item from the Walmart store, then while you are checking out and you are at the counter and the cashier is preparing the bill for you, then the cashier is making an entry for the data for the item that you're buying. So the entry that the cashier is doing an entry in the database system of that store, say Walmart in this case. Okay, and now after that entry, so the act of purchasing some item from the store is resulting in some change which is taking place at the store's database. Now there's another interesting database which is involved in this transaction, and this database is your bank database. How is this bank database coming into the picture? You're using a credit card. So when the cashier is asking you to swipe the card, then in that very process, when you're swiping your card, then that is resulting in a transaction which is directed to your credit card bank as well. Okay, so in this process, when you went to the store to buy an item and you made a payment at the cashier and you returned back with your item, there were two database systems involved: the banking database system as well as the store's database system. Okay, and now the banking database system would be the one from which you got your credit card. So if your credit card was from Citibank, then yes, the Citibank database system was active when you were doing this purchase. Okay, so that's one example where we are dealing with the database systems. Similarly, the other examples are also the cases where we interact with the database systems. If you are accessing your iTunes library, then there also you are interacting with database system. If you're using maps, yes, that's another example of the database system. Solar. Well, when you were registering for your summer course, you use Solar, and probably for the fall also you'll be using Solar database system as a student. And I also use Solar database system as an instructor when I have to make the grade entry for my students. Okay, so that is again a database system. Now, if you visit your doctor, your physician, and you've been visiting your physician, say for past 5 years, so probably in each visit that you're making to your physician or your doctor is making an entry for your parameters, health parameters, like your weight and your blood pressure, your temperature, so on and so forth. So even the doctor is maintaining a database, and where the doctor is making an entry for every patient on the day when the patient is visiting, and also might be recording the reason, like why is this patient visiting me. Is it a health condition? Is the patient sick, or it's just a routine visit? Alright, so there are a lot of cases in our day-to-day life where we interact with database systems. So the database systems are important, are integral part of our life now. Okay, now so when we have kind of taken some example of database systems, so let's try to understand the definition of each term, like what is a database. So well, if I'm asking like what is a database, I will need pens, so let me pick this here. So the point is, what is a database? So I like this definition, which says that the database will have the collection of logically related data. So this is important. You do have the data, but the data should be logically related. So as an example, let's stick to the Solar database. For the Solar database, which is our Stony Brook University database system, here we have the information for different students, we have the information for different professors and employees, so on and so forth. Now let's take the example of a student. Okay, so I'll write student right here. In Solar we have different students, so let's think about this student. So you're storing the information about the student in your database. So what information you will keep about the student, right? So let's think about it. You will keep the student ID, which is our SBU ID. You will have to store the name of the student. You should also store this feature, like whether the student is graduate student or undergraduate student, right? So this information you might like to keep. You would also keep probably the age information, the major, department, probably major and department may mean the same, address. So why am I taking this example? The reason I'm taking this example is that whatever information I'll be keeping about the student should be logically related. The fields or the properties that I'm storing for the student should be relevant to the university, should be academic information mostly. We may not ask for other information which is not related with university. Okay, now well, we can extend this discussion, and we can think of other data also. When you're talking about university, so you should have the data about professors, right? Why professors? Because professor data is related with this entity, which is university. right? So we are thinking about solar database system. So when we are thinking about solar, then we should think about all the data which is conceptually or logically related with the university. So that will involve the data about student, the data about professor, the data about different departments that we have in the university, and all these are logically related. Okay, and we may not keep some information which is not related with the university. Okay, so I'm just thinking like, oh, what could be the other information which is not related with the university that we may not like to keep here? Probably the stores, right? The stores which are in the vicinity of the university. We may not like to keep that information because that's not logically related with our database, which is the university. Okay, good. So now let's look at the database also. When you say database, then you might wonder like, what is data? Okay, so you're saying that it is a database is collection of logically related data. Now what is this data? How do we define data? So data refers to distinct, you can say that data is some distinct information which you can store or transmit in a computer. Okay, so that's the definition of data. It is a distinct information which we can store or transmit using a computer. And now if you want to know what is information, well, then yeah, we can define information as a fact. What is information? Information is a fact that you collect about any object. That object could be abstract or could be physical, like an object is student right here, which is a physical object. All right, so information, what is the information that you are storing about the student? The ID of the student, the name of the student, and the fact that whether the student is grad or undergrad, what's the age of the student. Okay, so all this thing is information. And when you store this information in computer, then that will become data. And when you store the logically related data about an object, then that will become a part of the database. I hope these things are making sense to you, but these are important definitions, and it will boost our confidence if we know about it. Now, what is a database management system? So this course is about database management system. So we have we had some discussion about database, and I hope that makes sense to you. What is a database management system? So database management system is a software which will help the user to create the database, to maintain the database, and to also query the database. And the most important thing is that it should help the user in accessing the database in a controlled manner. So this control is important. Okay, so we should have the database management system should help us in creating our database, maintaining our database, and also allowing controlled access to this database. Okay, so let's try to understand like, what is this controlled access? Well, we all access solar database system. Now the access to the solar database system is controlled. You'll ask, why do you say that this is controlled? Well, I cannot access all the information which is available on solar. I can access some information about those students who are registered under me in the courses that I am teaching. And I don't have all the information of even those students who are registered under me. So the information in my database is controlled, and I can access only when I provide my username and password. So The access has been controlled by the authorization and authentication. So this authorization and authentication is very important, and the DBMS system, which is the DBMS software, provides the controlled access so that we can avoid any unfair or we can avoid any misuse of the sensitive data which is being stored in our database. Alright, so this is an important aspect of DBMS. Now, there are some very interesting definitions, and I will encourage you people to make sure that you understand these things. So, fine. We looked at database, we looked at database management system, we have some understanding of data and information. Now let's try to understand these two terms like database application and database system. So what is a database application? So just a second, let me go back to the pointer. Database application is any program which accesses a database, right? So think of a scenario where we are writing a slightly complicated program which is database intensive, and our data is complicated. So what we have done, we are storing the data in the database management system, and the program that we have written will be accessing the database with the help of database management system, and will be using the language which is supported by the database management system. Okay, so think about an application which we have written which will take care of the registration of the student into different courses. So this program we might have written in the language like Java or Python, or could be your own favorite language. But the access to the database is being taken care by the SQL, or a language which is supported by our database management system. But this program that we have written, which is in our Java or Python, is accessing the database through the DBMS. Okay, so that kind of a program will be called a database application. Okay, so let me read that thing. A computer program that interacts with the database by issuing appropriate request to the DBMS. Okay, so database application is a computer program which is accessing the database, but it is accessing through DBMS, is a database application. Good. What is a database system then? Right, so the database system is will have a database system is the superset of the database application. So in the database system you might have more than one database application which are interacting with each other, and in database system we have a number of database applications. We also have database management system as well as the database. Okay, so I'll come back to this definition. Let me show you a picture. So hopefully this picture will make a lot of sense. So right here we are looking at a scenario where we have a database right here. Okay, and in the database we have data and metadata. I'll explain to you what is metadata, but for the time being just think that it is another data. So in our database we have data as well as metadata, and then here we are using a DBMS. We bought a database management system so that we can take care of the data that we have in the best possible way by using all the facilities that a typical DBMS system provides. So we paid the cost for that. Say we bought Oracle. Oracle is a very popular database management system. So we bought that and we created our database. Now when you have the data in your database and you created that using using Oracle DBMS, then you can write a program, maybe your student registration system in Java or Python. Okay, and you might write similar, maybe 5 or 10 database applications. Now all these things, if you take together, then that will form your database system. So what is this database system? So the database system here will have uh, some database applications, which are programs that are accessing database using DBMS. Okay, so everything taken together will form the database system. So if I ask you, give me an example of a database system, you should say Solar is an example of a database system. Why Solar is a database system? Probably there are a lot of database application programs which are running inside the Solar database system. And these database applications are probably taking care of different programs that we need to write for this Solar system to be effective. Okay, and then yes, in the Solar system we do have the database. We must be having some database management system. I don't exactly know which database management system has been used for Solar, but it will be interesting to know. Okay, now what do we have right here outside? Now these are the users which are accessing our database system. So that's the sales department, that's the stock control department. Well, when we are thinking about the Solar, then I might say that, let's replace the sales department with the administration department, and probably this guy right here could be replaced with either student or the professor. So we have different kinds of users who are accessing Solar system. Admin department, or the person who is working in the admin, and the other person could be a student or a professor. Now, alright, so I hope that this figure helped you in understanding the difference between the database applications and database system. There's this thing metadata, which I think I should explain to you. Now data is something which we understand. So as an example, we can have the data about students, and we might be storing the student's information like ID of the student, name of the student, address of the student, major of the student, alright, so status of a student, all those things. So that's the data. Now what is this metadata? Metadata is data about data. So let me use pen right here. Metadata is right here. Data about data. So what's the purpose of storing the data about data? Well, sometimes we need to even define the data. As an example, if I'm saying that I will be using age as a feature of the student, then I should say that what kind of information will I store for age? Is age going to be an integer value, or is age going to be a decimal value where I will have the age like 17.5? Okay, so the point is you also need to define the kind of data that you are keeping. One more example, the ID field that you have for a student, how will you represent that? Are you treating ID as an integer value, or are you treating that as a string value? Okay, so this all depends on us, like how do we define. So this information also needs to be stored in the database. Similarly, the phone number, how are you treating the phone number? Is that an integer, or is that a string with characters representing different digits in the phone number? Alright, so that's the metadata. Alright, so let me take you back to the previous slide. So now the database system is the collection of database applications that interact with the database along with the database management system, and the database itself will make your database system. Okay, good. So now let's look at some functions of DBMS. Like when you buy a database management system, or when you study about database management system, then what are the different things that a database management system can do for you? So the most important thing is the data storage. We want to store the data. Probably the data is huge. Probably we'll be doing a lot of update, a lot of retrieval of that data, right? So for that we need a system that can store our data properly. Okay, so the database management system will provide this feature. It will help you in data storage, efficient retrieval of the data, and convenient update of the data. So we will all learn about all these things when we learn the SQL. Now there's another very interesting thing, which is transaction. Okay, so what are transactions? Unfortunately, I will not discuss too much on transaction in this course because that is beyond the scope of ISC 305, but let me mention this thing, like what is a transaction in the database management system. So transaction is a special program which guarantees or which has the features with ACID properties. Alright, so it has ACID properties. So what is this ACID here? It has these features. A stands for atomic, C stands for consistent, I is for independent, and D is for durable. Alright, so now transactions are very important programs in databases which make sure that during the execution of these programs, and even after the execution of these programs, the feature of atomicity, consistency, independence, and durability of data is established. Okay, so these features should be guaranteed. So only those programs which ensures that ACID will hold are called transactions. Okay, so we'll call only those programs transactions in databases that will have the guarantee that they will make sure that atomicity is there, consistency is there, independence is there, and durability is there. Now, what are all these terms? I may not discuss that at this stage. If the time permits, then towards the end of the semester, I might consider discussing this in detail. But in any typical database course like CSC 305, this is important, and in that we do cover these things in detail. But I believe that this much is sufficient, like what are transactions and what are the important, when will we call a program as transaction and when not. Similarly, concurrency control is also a very important feature which the database management system guarantees. Well, again, concurrency control is the detail of the concurrency control is outside the scope of ISC 305 and also 543. But I can give you some intuition about concurrency control. So concurrency control is the concept in computer science in general, where we have the possibility of multiple programs or processes accessing a shared variable. Alright, so when you have multiple programs or multiple processes trying to access one shared variable, we want to make sure that only one of them gets to access that variable at a time. If we allow more than one program or the process to have the access to the shared variable, then that will result in a very inconsistent situation, and this is something we want to avoid. So concurrency control is an important concept in operating systems as well. Okay, so good news is that DBMS enforces that we have concurrency control. Now, although I am discussing these things in little detail, but for you, the thing which is important is that you should know these things. You should know the functions of DBMS. I will not say that you should memorize, but I will say that you should know these things so that if a question is asked about the functions of DBMS, your answer should be similar to these points. If you are close to these points, you are good. But yes, your answer should be similar to the points that we have here. Now, what is recovery service? So recovery service is intuitively easier to define. Suppose you had a database and you were using a database management system. Something went wrong. You had some transaction and something failed in the transaction. Now, the DBMS system is so robust that it will have the feature of recovering from the failure, which is a very important feature to have. Okay, so this recovery service will make sure that in the event of some incidents like power going off, something crashing, your recovery measures will take care of recovering your database from failures. Authorization services are important, and we do have the authorization in DBMS, and that will result in controlled access to the database, which is a must. Similarly, we have the support for the communication as well. So if you have if you want to access the data which is distributed, then probably we will have the support for data communication. Integrity services, again I'll say that just remember that integrity services are the services which are provided by DBMS. We will not go into the details of that. And similarly, utility services. Okay, so these were some functions of DBMS. Now, what is this slide about? Well, this is about tables. And what is a table? Well, the data that we store in database, and that too in relational database, is in the form of table. So what we will do here, in ISC 305 or ISC 543, we will be studying relational databases. What are relational databases? In the relational databases, all the information that we store is stored in the form of a table. So right now you are looking at a table. And what is this data, this table showing? This table is showing the fact that we are storing the information about items. Okay, so I should have used the stylus. Item, right? So the item which is available in any store. There is a store, and that store is selling different items. So now this item will have the properties like item ID, the name of the item, and the price. Alright, so how do we store this information in a relational database? We will store that in the form of a table. Okay, so alright, let me add this detail here. In a relational database management system, so R is new here. DBMS we kind of understand. Database management system, R is for relational. Alright, relational database management. In relational database management system, data is stored in tables. Okay, and these tables are also called relations. Alright, and what is this relation? Relation is a concept from maths. In mathematics, we do have relations in set theory. Alright, so don't worry about it. We will have a dedicated lecture on these concepts, like what is a relation, what is a relational database management system. But just since this we have this example right here, we'll try our best to understand what we have here. Okay, so here we have the data about item which is being sold by some store. Now for this item we have these properties, right? It is up to us, like how do we define the item. So the data that we are keeping in our database which defines an item are the ID of the item, the name of the item which we are calling as product, and the price. And so now you can see that we have 4 such items here in our data, in our table. The pocket knife, its ID is 1. Then you have compass, its ID is 2. And the pocket knife nail is $4.5. Compass is $10. GPS system is $500. The ID of GPS is 3. Then we have the map measure, the ID is 4, and its price is $4.90. Okay. Now this is a very interesting and very important concept. Views. What are views? So let me, before I go to the views, let me discuss the solar system again. So let's talk about solar right here. Okay, so I'll use the example is solar. Now let's think about the different kind of users who are using solar. So we have students. Sorry about that. Let me see if I can get the eraser. Okay. Alright. So here, who is using solar? Students. Right. You register for course. Students. And then we have professors. Then we have professors. And we have admin people. Alright. Now, so what do you think? I mean, will you let's log into Solar. I'll ask a student to log into Solar, and I'll log into Solar at the same time. So you will get you might have guessed that we won't be the Solar that comes to me and the Solar that the students gets to see are supposed to be different. So the point is that the same database system, which is Solar, will provide a different view to me compared to the view that it will provide to a student. And similarly, the view that it will provide to the admin staff would be totally different. So the point is that for a database system, it's possible that this database system will be supporting different class of customers or different class of users. Alright, so here for this solar system, we have different class of users. We have students as one class, we have professors as the second class, admin as the third class. We can think of more classes here. So the requirement is that although we have one huge database system, we should customize our database system in such a way that the different class of users are having a look at different part of the data, and we should only let that part of the database visible to a user which is required for the user. Like for students, I think probably the students should not have the access to the payroll system of the professor or an employee. Okay, because that is sensitive information. That is an information that is supposed to be protected. And similarly, for a professor should be only allowed to access the records of the students who are registered in his course or her course. Okay, and that information is also very limited and should be very limited. The professor should be given access to only those students who are registered under that professor's course, and even the information of the student should be limited. Alright, so that's the point. And this feature, which is customization of the database as per the class of the user, is achieved using views. So what does a view allow? View allows each user to have his or her own view of the database. Also, in a way, it is providing the customization. It will allow each user to have his or her own view of the database. And how does it do? Well, towards the in the final week, I will show you some examples like how can we create views. So views can be created using SQL statements. We will look into those and we'll learn about views later. But let's try to understand the importance of views. Like, why are views important for us? Now what view is doing, view is essentially some subset of the database, right? That's what we want to have. We want to provide a subset of the database to a class of a user. And now what are the benefits? This is my favorite question and is a very important concept. Probably someone may ask you this question in interviews as well. Like, what are the benefits of views? It will provide security. Okay, so when you're making sure that you are allowing only the subset of the data to be accessible to a class of a user, then that way you are enforcing security. My payroll information will not be accessible to those people who are not supposed to look at my payroll. Similarly, there could be some other confidential information which can be hidden in this way. So that is helping us with the security. That's one point. What's the other point? The other point is about customization. And if you customize it, you will reduce a lot of clutter. Okay, and it will make the appearance a lot more simple. So it will provide a mechanism to customize the appearance of the database. Alright, and it will present a consistent, unchanging picture of the structure of the database, even if the underlying database changes. So that's another interesting feature of the views, which if you want to understand how is that attained, then this is little complicated to understand right now. But if you're interested in knowing about it, you'll have to study a little bit more. And that boils down to the tree schema architecture. Probably I'll discuss that towards the end of the semester, and then I'll tell you, like, how does that help in views. So the point is that you can make changes at a lower level, and those changes will not reflect the changes at the level of the views. Okay, so because of which it will present a consistent, unchanging picture of the structure of the database. Alright, even if you are doing some modifications at the lower level. So these are some advantages of views. Okay, nice, great. Now let's look at the database management system components. Like what do we need to have in order to get our database management system running? So yeah, nothing will work without a hardware. That's the first thing we should have. Now it depends on our need. How big is our data? So if our data is not that big, so probably we are good with one personal computer. But if your data is going to be really huge, probably you'll think about clusters, which means a lot of computers connected together, or it could be just the simple, computers connected with each other using some network connection. So it will have a network of computers. So the hardware need depends on your system need. How big is your data? How big is the organization for which you want the database management system? If it's very simple, just one personal computer is good. Otherwise, you might need networks of computer. Fine, you got the hardware. Now, will the hardware work? No, probably not. Right? So the first software that you need to have on a hardware to start using it is the operating system. Alright, so operating system is the first thing that you need. And what is an operating system? Well, you should know that definition. Operating system is a system software. It's a system software that makes hardware usable. That's my favorite definition. You might find other definitions of operating system as well, but I like this one. Very simple and makes a lot of sense to me. Operating system is a system software which makes the hardware usable. So if your operating system crashes or there's some bug in operating system, you can't use your machine. Alright, so you'll have to either reinstall your operating system, or probably you'll have to reinstall your operating system. And once the operating system is running, then only you can use the remaining softwares that you have on your computer. Okay, I got the hardware, I got the operating system. Now when my operating system is working fine, now I should think about the other softwares. So we are discussing DBMS, so I should get a database management system. I shouldn't say that we have to buy DBMS. There are some open source DBMS as well. Like MySQL is an open source, and so you don't need to buy MySQL, but you might have to buy MS Access and Oracle. Alright, so there are some paid DBMS. You might need the network software if you have the distributed database, if you want to create the distributed DBMS. Alright, and then you might need more application programs. You might need to install probably Java if you're writing your program, application program in Java or Python. That could be your favorite programming language. Okay, yeah, so we are done with the software. Now data is the most important part, because all this exercise that we are doing, learning DBMS, is about our data, right? So we should have the data. So as an example, say there's a new university in Long Island, say some SUNY Long Island, a new campus has opened up, and we want to store the data about our students, right? So everything we did, we bought the hardware, we installed the software, we installed MySQL. Alright, now the students, they started coming in and they are registering, so we have a data and we'll start putting the data in. Alright, so the data is also a very important component of database management system. If you don't have data, we don't need to worry about anything. We should not study DBMS in the first place if we don't have data. Good. So now let's get into an interesting topic of database design. Now, what is there in the database design? Before we start implementing the database, right? Before we start storing the database, before we start, writing the query language, we need to design the database. We need to conceptually work it out, like how are we going to organize our database. This is very, very vital, and interestingly, you will do that. So I already gave you some idea about the project in our very first lecture, and some of you have already started thinking about it. I did receive some emails. Well, so in the first stage of your project, you will do the database design. So in the database design, you will determine the structure of your database, like how will you organize it. And coming up with a good structure, that means coming up with a good design, is very, very vital in the performance of the database. Now, the point is, you can come up with many different designs. Alright, so there are many different designs possible. Some of those would be horrible and some of those would be good. So we will look at the approach also, like how do we evaluate which design is better. Alright, so well, we will learn about the normalization, which should happen in the last 2 weeks of the semester. So normalization will help us in identifying or evaluating the design, like the way I'm thinking of designing my database, does that look good or not? If it is not good, then how can I refine the design? Alright, so probably I missed out this definition, like what is the design? What is database design here? So the database design is a process in the translation of an understanding of the application into the design. Alright, so what does it mean? Probably I gave you this example that, assume that you're working in a software company and you went to the client, and the client, the same university, let's think about a SUNY campus which has come in Long Island, and they are looking for database designers, they are looking for database professionals who can design a system like Solar for them. So they will mention the requirement in the written statements, right? And they will give you the requirements in the written statements. Now from those statements that you got, which were in plain English, you need to translate that to a system like Solar. So how do you do that? So the first stage would be database design. Okay, you'll have to make a blueprint for your database system. Alright, so that's what we discuss in database design. Alright, so there are some design rules. So the design rules will restrict the number of possible designs. Some designs will be ruled out. So what will happen very soon is that I will ask you people to come up with your project ideas, and then I'll say, okay, now is the time you design this thing. I'll ask you to create your RDM. There'll be a deadline, you will submit the RDM, but before that I'll teach you how to design an RDM, and then I'll ask you to present your RDM, and if I find anything wrong in your RDM, I'll ask you to modify your RDM. Alright, so there are strict rules that governs the possible design. So if your design is not following those rules, then I'll ask you to modify your design. Alright, so that's about database design. Now to MS Access, right? So we will be using MS Access initially to create a database, and then we'll learn a little bit of SQL using MS Access, and we will learn some tools which are available with MS Access. So let's try to understand what is this MS Access. So we have different database tools available. As I mentioned, we have Oracle, we have MySQL. There are so many versions of SQL stuff like MySQL, and there are a few more. Oracle is there. Microsoft has MS Access. That's the one we are going to use initially. So what do we have here? It's a very simple system and it's very easy to use. That's probably the reason why we use MS Access in this course. Now there are some drawbacks also. The simplicity that we have in MS Access, it comes with a cost. What's the cost? It supports only limited number of simultaneous users. So if you have to design a database system where probably you'll have hundreds of simultaneous user using it, I'll say maybe MS Access is not the way to go. Okay, so it has a limitation. It's limited to only few simultaneous users, limited number. But it has the advantage, which is GUI interface, that makes the thing a lot easier. So even the SQL thing you can write by just using GUI. I'll show you how to do that. So that's an advantage. And for those people, I was doing this research like why is MS Access so popular, and if it is possible, if it is popular, then in which community it is popular. So I got to know that the management people, they like it a lot because they don't want to code, they don't want to program. So for management kind of people who don't like programming, this GUI interface is very handy for them. Now this is a negative feature of MS Access, which is non-standard SQL. Alright, so what is SQL? Probably I told you about SQL. SQL is the query language of the relational databases, and it stands for structured query language. Okay, so SQL stands for structured query language, and which is one of the strongest feature of the relational database. Now with MS Access, this is non-standard. So what do we mean by non-standard SQL? Right, this is something we need to understand. So there's this thing called ANSI, American National Standard Institute, ANSI. So ANSI is an organization which comes with the standard. So ANSI has the SQL standard also, ANSI SQL standard. So ANSI SQL standard comes with the standards like what SQL should have. If a vendor wants to provide its version of SQL, then what all that vendor should implement. So these SQLs, these relational database systems like Oracle and MySQL, they follow this SQL standard. Oracle and MySQL, they follow the SQL standard. So the SQL that they have is that follows SQL standards, the ANSI standards which they have set up for SQL. Unfortunately, MS Access does not follow that. It has its own standard for SQL, which is slightly different from the standard SQL, and I'll highlight like how is it different from standard SQL when we are writing SQL. Okay, good. So what do we have in an Access database? We will have the database name. We are just about to do it. I'll do a demo today, so I'll show you how to create a database in MS Access. So it will have a database name, and once you create a database, you can have multiple tables inside the database. Probably in your project you are going to do that. I put a condition that your project should have at least 5 to or 10 entities. That means you will have at least 5 to 10 tables, much more than that because you'll have relationships as well. And now in each table you will have collection of fields. So these fields and attributes, all those things I will explain in next few lectures. Okay, so the table that you have, the table will have different columns. So when I am saying fields, then this fields means the columns of table is called field. Sorry about my handwriting. Alright, so what are the fields? The fields are the columns of the table. Alright, and we'll have the type of each field. So when I do the demo, probably I'll explain to you what are these these fields, what is the type, how can you change the type, and all that. Now, what are the advantages of DBMS? Well, we will have the control. Well, this is a very important topic. Let me explain this. Redundancy. And redundancy is a technical term in database. We need to understand what is redundancy. Well, the problem if you don't have a DBMS system is that you will have a lot of redundancy. So let's think about a scenario, like we have a university system and we want to organize our data, and we don't want to use DBMS. We don't want to, we want to make it very, very simple, and we just want to have files. All the records that we have, we'll keep that in file. Alright, so let's think of the scenario that we have students, and the students record we will be saving in one file, a file with all the probably we have some 30,000 students. Let's store all the data in one file of 30,000 records. Now what will happen, since we have different departments or different sections in the university? We have administration, as I mentioned, we have different departments. Let's think of computer science department, let's think of administration department. We can think of more departments. Now each of these departments will need the student's record. So if we are keeping that in file, then probably we will have to make multiple copies of this file. And a copy of that file would go to the computer science department. A separate copy of that file with the student's record will reside in admin department. Similarly, we can think of other departments also which will need the student's record. Now what will happen is that, first of all, what we are doing, we are wasting space. If we could keep the data at a centralized space by using a database management system, we'll have just one copy of record. But right now what we are doing, we are making multiple copies of that file. At least in this case, when I have two departments like admin and computer science department, we are making two copies of the file. Now assume that some information is changed by the student. Say the student wants to change the first name, and that thing has been notified to the admin department. So the name of the student got changed in the admin department, but that name is not changed in the computer science department. This can happen. Why is this happening? This is happening for the reason that you have multiple copies of the same record. Okay, so this is called redundancy. When you have multiple copies of your data, then that is called redundancy. You have duplicate data, and which is a bad news. It results in a number of inefficiencies in databases. A lot of problems we can get into if we have redundancy. So with the database management system, we can control the redundancy because we will just keep one copy of the data. Okay, and that will be probably centralized. We'll have the data only at one place in that database management system, like Solar. Now if the computer science department wants to access, then somebody in CS department will log into Solar and will update the data if it has to be, and the CS department will be updating the data which is central. So whatever change CS department is doing, that change can be seen by the admin department. In the same way, admin can make some change, and that change could be visible to all the people who are concerned. So that's a big advantage. Our DBMS will control the redundancy by making sure that there is single copy of the data, centralized, which is accessible to most of the users. Data consistency, this is another feature. Well, again, consistency is something we don't discuss in detail, so I will just say that take it as it is. Consistency, you should say that DBMS. Redundancy is easier, intuitive. I can give you some idea about consistency as well. Well, there is something called as constraints. Okay, so in the databases we have constraints as well. Constraints means the conditions, like what values data can take and what values data cannot. So when you create your database, you define the constraints as well. Let me give you an example. Assume that I am teaching ISC 305 in the classroom, and the classroom has the capacity of 120 students. So now this classroom capacity, which is 120, is imposing a constraint that I cannot have more than 120 students in my class. Alright, so when I create a table that is representing the students registered in my class, I should make sure that the number of registered students never crosses 120. So that I should specify in my constraint. And if any attempt is made to register more than 120 students, that should result in an alarm. So fortunately, these kind of features can be incorporated in the database management system by defining constraints, and they will take care of data consistency. Alright, so data will be stored as per the requirements of the constraints. Now sharing the data should be intuitive, which I kind of gave you the hint in the data redundancy. When you have just one central data repository or storage in database, you can give the access to the different user, and they can access the data. So sharing the data is very easy. Similarly, the data integrity is kind of related with consistency. Integrity means that making sure that the data is correct and consistent. Maintenance is another advantage that we have with the DBMS. It has some features like recovery. So I'll say that it's good if you just remember these features. You don't need to go into the details because we don't cover the details in this course. Disadvantage, right? So nothing comes for free. If you have some advantages, you may probably have some disadvantages as well. So what's the disadvantage of DBMS? Well, it's a robust system, but it is complex too. There'll be a learning curve. You'll have to learn how to use a DBMS, right? So in this whole course, we'll learn how to use a relational database system. Okay, so these are complex, difficult to learn. Okay, and then for most of the database management systems, you need to buy those. Like Oracle, you will have to buy. So that comes with a cost. You should be ready to pay that cost. Cost of conversion. Well, assume that you were using a relational database management system. You spent good amount of money. You bought Oracle, and then you realize that your need has changed, right? So now the data that you're getting is something which will not fit in relational database. So probably you need to buy another database. So this transition from the existing database to a newer database is expensive. So this cost of conversion is expensive. Alright, so that could be a disadvantage. So what's the message? If your database is simple, then probably don't go for database management system. If your data is very simple, it has some 3 or 4 fields only, then probably not going to DBMS is advisable. What's high impact of failure? Well, if your database DBMS crashes, then that's a bad news. Alright, so you need to find out some database admin or somebody who knows the system pretty well, and then that person will have to come and fix your DBMS system. So that's another disadvantage. Alright, so if you want to know about the history of DBMS systems, like how did it evolve, then this is an interesting picture right here. So around 1955, the data got a little complicated. We started, getting a lot of data. Then people started thinking about organizing it, managing it, and the file system was the first thing that came to their mind. And they started managing the data with file systems, but they very soon realized that file system is not the best way to go about it. And then the research started happening, the concept of database management system came into existence, and the first model that people came up with for database management system was hierarchical. That happened in around 1965. But the hierarchical database system had some drawbacks. So that drawback resulted in that resulted in another model of the database system, which was network model. After network, there was some spatial model, and then came the most I'll say important and the best model of the database system, which is relational database management system. And this relational database management system has been the most popular database management system, so much so that even now we have a lot of database systems which are relational in nature. And in fact, we will be using the relational database management system in this course. Okay, so recently, I'll say not recently, from 1990, people they moved on to the object-oriented database system. So object-oriented database systems are also there, but they are not as popular as relational database management system. Okay, good. So now let's look at this SQL thing, like what is SQL, what is query, and what is non-procedural. So all these things are important in our discussion. So what is a query? Let's try to understand query, because query is something which will reappear in our discussion of the relational database. Now, when we have our database, we want to retrieve some information, and that information retrieval happens in the form of a query. So as an example, if for some reason I want to find out the list of the students who were there in any of the course that I taught in Stony Brook University, so I'll have to issue a query. So that query would come from a question. So the question is my interest. I want to know those students whom I have taught in Stony Brook University. So I'll have to create a query for that, and I'll fire the query, and if the query is written properly, I'll get the corresponding result back. So that's the concept of query. Now the interesting thing about the query is that it is non-procedural, right? We need to understand what is non-procedural. It is one of my favorite questions. Procedural and non-procedural. So if you understand non-procedural, you will understand procedural as well. What is non-procedural? So in non-procedural, you specify what you need. What you need, you specify. You do not specify. You don't specify. You don't say or specify how to get that. How to get that. Alright, so in my example, if I have my database which is relational, I'll write a SQL query, and I'll say that I'll write the query in such a way that I'll specify what I need. I'll say give me the name of the students. Definitely that will be in the form of a query, whom I have taught. So I will just say I want this students whom I have taught in Stony Brook University. I will not specify how should you retrieve that thing to me. So that's the non-procedural thing, right? So non-procedural is also sometimes called as declarative. declarative. Means I'm declaring, right? This is declarative. I'm declaring, I'm saying that, I want this. And I'm not giving you the procedural details. I'm not telling you how should you retrieve that to me. This procedural detail is something that the database system has to figure it out. Alright, so that is one of the strength of the relational database, which is SQL. So this SQL that we have, which is the query language of relational database, is declarative in nature. Alright, good. So now this slide I will skip because anyway we will be doing it and I don't see a lot of information here. Now let's do this exercise, the last thing in this lecture. So this exercise is for you as well, and I mentioned to you in the first lecture that you will find something like are we on track exercise. So I will encourage you to do this are we on track exercise because that's how you will learn, that's how you'll practice the concept which I am teaching in the class. Now for this exercise, which is are we on track, we will be using MS Access. So if you are having difficulty with MS Access, please let me know. There were some students who reached out to me with the problem that they are facing in getting the MS Access. So I'll see how can I help them. But for those who are already having MS Access and it is working fine with them, I'll encourage them to do this exercise. So for this exercise you need this data set SBU active project, which is an Excel file, and I have already uploaded that on the Blackboard in the data sets. So if you go to the Blackboard, then in the folder where you find your lectures, you should also find a folder named dataset, and in the dataset you will have SBU active projects. Please download that because we will need that file for this exercise. So what do we have to create? We need to create a database, and these are a few things we will be doing. I hope I remember these things, and if not, I'll come back to this slide. Okay. Alright, for this are we on track exercise, let's see where we are. We have this file. We need a file for this exercise, and this file has all the records that we want to pull in MS Access, and we'll use that to create a table. So what you should be doing, I have already done that. This file which is there on the Blackboard, you need to download that somewhere, and I have downloaded that in my folder which is in summer 2020 ISC 305503. If you go there, then in the data sets I have this file. Let me show that. How does it look like? So this is the file, a big file with some 57,000 records. This file we will use. The data from this file we will pull in the table that we are about to create. Okay, so you need to first download this file from the Blackboard. It's already posted in the datasets section in Blackboard. So please download that in a folder, and you should know where exactly you download it. Then from here you need to access MS Access. Please type ACCESS access in this icon right here. I'll get to MS Access. Now from here you have this option. You can use blank database. So it will give you the option like what database name you want to keep. I'll say SBU awards. That's the instruction. The instruction says that you need to create a database with the name SBU awards. Let's create that. So it's asking, do you want to replace the existing one? I'll say yes. Okay, so I replaced the one because I had one. Probably you will not get this error if you're doing that for the first time. So now from here we will go to create. We are creating a table. So you can see a number of tabs right here when you open this MS Access for the first time, and when you have created your database with the name like I created with SBU awards, go to create. We want to create a table. I'll pick table, and then for this table I'm getting the data externally. So here I shall say external data, and then when I say external data, then it will show me all these options. So I need to pick the new data source. Right here I'll say that I want the data from a file, and my file is Excel file. So when I do that, it will show me this option. I will browse, and by browsing I will go to the folder where I already have this downloaded file, dataset. I'll select that, we'll say open, and then I'll say OK. Now these are some options that it will give, so you should be careful. So it's saying is the data available on sheet 1? I will say yes. Then it will say, like, in the file that you have, do you want to keep the first row as the column heading? I'll say yes, because if you go back to the file, then you will find that the first row that we have in the source file is the heading of the column, and I want to use that column heading as the heading of my columns in the table as well. So I'll say yes, please consider the first row as the column headings. I'll say next, and then you will get some options here. If you want to change the column name, you can change right here. You can change the type also. So if you're not happy with the AWD number, you may call that as AWD, and you can remove the space right here. So the point is, you can change the field name right here, highlight. It's up to you if you want to do it here, or you can do it later as well. So I'm not doing anything right now. And this very column has its data type as short text. If you want, you can change that here itself, but we'll do that later. Let's move on. Now this is an important option that MS Access will give you. So MS Access will ask you that, do you want to add another field in your table? And this new field, if you're adding, would be treated as a primary key. Now primary key is a very important concept which I will discuss in the next class, but for this case, for this demo, we will say that yes, please add a primary key for me. So when you're saying that let Access add primary key, so right here it is adding a column in my table, and it's calling that as ID. We are fine with that. We will let MS Access do that for us. Then we'll say next. And right here, it will ask you that, do you want to give some name to your table? I will say yes, let's name that. I'll say awards. Okay, and this is an option we don't need to select right now. Later on, after a few weeks, we will use it, but not today, because we want to keep our life simple. Alright, so don't do anything here. You should say finish and say close. Alright, so if you click this thing, now you have a table created, and this table has been created on the basis of the file that you used. Alright, so we were able to create our first database with only one table there called awards. So alright, I would like to close the other two tables because there's nothing there. The only table that I have is awards. Okay, now there are some exercises. This is right here. Yeah, let Access add the primary key. We did that. Name the table as awards. We have done that. Do not use select analyzer wizard. We did not do that. And saved SB awards. We did that at the first stage. And then make the table more readable, adjust the column width. So let me do that. What do we mean by that? So here you can see, it's not looking good. So if you want, you can make this bigger. It's not difficult. It's very, very simple. Just drag that a little bit. Okay, sorry about that. So this is the exercise for you to please play with this data and make sure that you are able to work on MS Access and you are able to create this table. So that's the exercise. Make the column a little bigger so that so that the data is more readable. I'll make ID small. Okay, so please do this exercise. I will show you one more thing here. I hope you'll be able to do it, right? It's very trivial. Now from here you can go to home, and when you go to home, now you'll get this option right here. So this table, right now you're looking at the table in the data sheet view, and in the data sheet view you are able to see all the records, right? So you don't see all the records, you can see only till 30, but you can drag down and you'll see all the records in your database or in your table, but that is in the data sheet view. If you want, you can change the view to design view, and in the design view now, if you want, you can change the property of your table. So what do I mean by property? So for this table, which is the awards table, you have these fields. The ID which was added to it by MS Access, it was asking us for permission. We did give the permission to the MS Access to add this field, which will be used as a primary key, and that's the reason you have a key symbol right here. Now right here, if you want to rename the field, you can do that. Alright, so I'm just renaming this award number by AWD. There was a space, I removed that space. So now award PI name, I want to change the name of the field, right? So that's what I'm doing. Okay, so here you can rename the column of your table. And on the right hand side, on the left hand side, you have the name of the column, and the right hand side you have the data type. So ID, it's a number, award number is a text, PI number is a text, that means a string thing. Now if you want to change the data type, you can do that, like budget. So budget is a number right here, but I can change the budget, right? So I will pick currency. Alright, so you can change the name of the field, and you can also change the data type. Okay, so what I'm doing right here, the budget which was number, I'm changing that to currency. And then what we will do, we want to go back to datasheet view. It will give us a message that, do you really want to go ahead? Do you want to save the changes that you've done on the table? We'll say yes. It will give some warning, we will ignore that. Okay, now you can see the change. What did I change? The column name was changed, and this column name was also changed, which I changed in the design view. And from after that, I'm back to the datasheet view. And I also changed the budget. I made the budget data type to be of currency. Okay, so this was a very simple exercise, and I'll encourage that you should do it because this will give you some confidence. And it's not very difficult, but initially you will have some issues with MS Access. This creates some issues, although the system is very simple to use. Alright, yeah, thank you so much, and let me see if I have anything left here. Okay, so the last slide that we have here is about our objectives. So it says that in this lecture, did we achieve these objectives that we had set up for ourselves? Did we understand the common use of database systems? I believe yes, we did. Did we understand the meaning of the databases? Did we understand the meaning of database management systems? I think yes, we were able to look at the different components of DBMS systems. We looked at different functions, advantages, disadvantages of DBMS systems, and we also built our first database. Alright, so we are done with the second video lecture. I'll see you in my third video lecture. Bye bye. Take care.